Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science uh, in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NEET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 27. In which I'm going to discuss relativistic quantum mechanics. And today your quantum mechanics is going to be completed, guys. Okay, so your quantum mechanics is going to be completed in 27th lectures. Okay, this is the last lecture, which is 27th lecture, and in which I'm going to discuss relativistic quantum mechanics. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'll start now. Relativistic quantum mechanics. Relativistic quantum mechanics. Meanwhile, let me check whether I'm audible or not. Relativistic. Yes, I'm audible. So I'm going to proceed further. Okay. Okay, guys. So relativistic quantum mechanics we are going to study. Okay. So in relativistic quantum mechanics, we know E square equal to P square C square plus M naught square C to the power 4, right? And also we know value of M is M naught gamma, and value of length contraction, right? This is L naught upon gamma, and value of tau is gamma time dilation, right? That is gamma tau naught. Okay, and also we know this E, the operator value of E is I h cut del upon del t, and an operator value of P we know minus iota h cut del upon del x, or we can write minus iota h cut del in 3D. Okay, so these point also important, you need to note down. Okay, so from here this we know, right? We can take psi on both sides, so this is going to be E square psi equal to P square C square plus M naught square C to the power 4 psi. Okay, this we can do it, right? In quantum mechanics. And now we'll write the value of operators. So this is we know, so this value is E square is this one, iota h cut del del t, right? If we square it, so this is going to be minus because iota square is minus 1, right? I minus h cut square del upon del t, del square upon del t square psi, this, right? And value of p square we know, so p square is this, p is iota h cut del upon del x, p square value is going to be minus h cut square del upon del x, you know already, right? So this is minus h cut square, this we can write this one, right? Minus h cut square del square in 3D. Okay, del square plus this is m naught square c4 to the power psi, we can write this. Okay, so now what we can do is we can multiply by 1 upon h cut square in both sides. Okay, so this is going to be 1 upon h cut square c square. Okay, h cut square c square minus del square minus h cut square del square psi upon del t square, and this value is going to be this is h cut square. Okay, so minus h cut square upon h cut square c square del square plus m naught square c4 upon h cut square c square psi, this is also psi. Okay, this is also psi. Okay, so now h cut square will get cancelled, so this value is going to be minus 1 upon c square del square psi upon del t square, right? Del square psi upon del t square. Okay, and this value is going to be this this one h cut will get cancelled, minus del square, right? So we can take this in right hand side, so this is going to be minus del square psi, and this is going, my apology, so minus minus plus, and h cut will get cancelled, right? H cut, so 1 upon c square. Okay, 1 upon c square will remain here, so because we have taken this in left hand side, so minus sign become plus, right? And this is h cut square c square h cut square, and this is like c will cancel c4, c square will cancel c4 by c square, so this is going to be m naught square c square upon h cut square psi. Okay, we'll take this in left hand side. Okay, so this is going to be minus, and this is going to be equal to 0. Now we can take multiply by minus 1, so this is going to be 1 upon c square del square psi upon del t square minus 1 upon c square we have taken common. Okay, minus del square upon minus del square psi, so we can write like this. I will take del square upon this del square outside psi minus m naught c upon h cut whole square psi equal to 0. We can do like this. Okay, so we can write this value is equal to this. So this is this operator. Okay, this is I'll tell you, this is 1 upon c square del square upon del t square minus del square. Okay, this value is called D'Alembert principle. Okay, D'Alembert principle. Okay, so this is like D'Alembert principle. Okay, so this is called D'Alembert operator. D'Alembert operator, right? This is a French name, guys. It's a French scientist. We say like normally in India we say D'Alembert operator, right? But this is not D'Alembert's operator. It is D'Alembert operator. Okay, D'Alembert operator. It's a French name, guys. Okay, so this is D'Alembert operator. Okay, so we can write this one. Okay, 1 upon c square 1 upon c square, okay, del square psi upon del t square. Okay, del square 1 upon c square del square upon del t square minus del square. This is D'Alembert operator. Okay, so now this is going to be del psi here we have made some mistake. I think this is c square is also here, guys. This one. Okay, here c square is also here, so h cut square c square, right? C square is also here, right? Okay, so this there is no this one, right? There is no there is h cut square c square. Okay, so this will get cancelled, so this is going to be like this. This is just this one plus. Okay, and this is going to be this one. Okay, so 1 upon c square del square del t square minus del square psi. Okay, and this is, so this is this one. Okay, so this is the 1 upon c square del square upon del t square minus del square. Okay, so this is D'Alembert operator. Okay, not D'Alembert operator. Okay, it's a D'Alembert operator. Okay, so this is called, so we can write here del psi minus this D'Alembert operator psi minus m naught c upon h cut whole square, m naught c upon h cut whole square okay, so square psi equal to 0. So this is called KG equation, guys. Okay, KG equation, KG equation. KG equation means Klein-Gordon equation. Okay, Klein-Gordon equation. So this is Klein, Klein-Gordon, Klein-Gordon equation. Okay, very important. This is Klein-Gordon equation, or this is also Klein-Gordon equation. Okay? Same thing. KG equation. Very important, guys. You need to note down, because this question is asked in many exams, and this question is asked in USET exam of 2024. Okay, guys. So this is Uttarakhand SET exam. This question is asked. Just have to ask the exact formula of this one. The formula for KG equation, Klein-Gordon equation, that was asked in Uttarakhand SET exam, right? So different options are given. You need to select the correct option, right? So important thing, and so you need to note down it, okay, and memorize it. Very important. So this is the Klein-Gordon equation, okay, KG equation. Okay, and this is not D'Alembert, guys. This is D'Alembert operator. Okay, D'Alembert operator. So D'Alembert operator, or we can say like Klein-Gordon equation like this. D'Alembert operator psi minus m naught c upon h cut whole square psi, and this is guys, we know, since we know here, right? This one, h cut upon m naught c, that is Compton wavelength, right? Compton wavelength. Compton wavelength. So this is Compton wavelength, guys. Okay, this is 1 upon Compton wavelength. Okay, so this is we can say lambda c, or we can see 1 upon lambda c. Okay, lambda c is Compton wavelength. Okay, so this is the Compton wavelength. This is D'Alembert operator. Okay, and this is KG equation, Klein-Gordon equation. Okay, this is the exact pronunciation, guys. Okay, well, so this is now some points I would like to write. Some points is in relativistic quantum mechanics. In relativistic quantum mechanics, Schrodinger equations are not valid. Okay, Schrodinger equations are not valid. Schrodinger equations are not valid. Schrodinger equations are not valid. Not valid. Okay, valid. So only Klein-Gordon KG equations are valid. Okay. Next, Solution for Kg equation. Solution for Kg equation. Klein-Gordon equation. Okay, Klein-Gordon equation. Klein-Gordon equation. Okay. Okay, solution for Kg equation. Okay, so this is psi, which is function of xt, is going to be equal to a e to the power iota px minus et upon h cut. Okay, so this is the solution for Kg equation. Okay, psi which is function of xt equal to a e to the power iota px minus et upon h cut. Okay, well, and Kg equation is only valid for spin s equal to 0. Okay, for particle whose spin s equal to 0, for spin s equal to 0. Okay, so from here, since we know E square equal to P square C square plus M naught square C to the power 4, right? So from here, value of E is going to be plus minus root P square C square plus M naught square C to the power 4. Okay, so there is both, you can see there is both positive and negative energy eigenvalue. So there is both positive and negative energy eigenvalues. Eigenvalues are possible, right? Because the equal to plus minus root p square c square plus m naught square c to the power 4. Okay, but Kg equation, Klein-Gordon equation, Kg equation doesn't include spin of particle. Doesn't include spin of particle. So it is only valid for spinless particle. Spinless particles. Okay, that is s equal to 0. Okay, so there is you can see the both positive and negative value of eigenvalues, right? So Kg equation does not include spin of the particle, right? So it is only valid for the particle whose spin is 0. Okay, next is Dirac hole theory, guys. Okay, Dirac hole theory. Dirac hole theory. Dirac hole theory. So we know we have this E equal to plus minus root P square plus C square plus M naught square C to the power 4, right? So from here, if P equal to 0, so in that case E is going to be plus minus M naught C square, right? So like this, these are the equations. So this is like this. Okay, this energy is minus m naught c square, okay, and this energy is plus m naught c square. So m naught c square, okay, and E values are this. Okay, so now I will write Dirac Hamiltonian and Dirac equation. Okay, so Dirac Hamiltonian, Dirac Hamiltonian, Dirac Hamiltonian oblique Dirac equation. Dirac Hamiltonian oblique Dirac equation. Okay, guys. So we know the Dirac Hamiltonian is H equal to C alpha dot P plus beta m naught c square. Okay, so Hamiltonian is Dirac Hamiltonian is C alpha dot P plus beta m naught c square. Okay, where alpha and beta are 4 cross 4 Dirac matrices. 4 cross 4 Dirac matrices. So 4 cross 4 Dirac matrices, okay. And the value of alpha is 0, sigma I 0. So this is the value of alpha, guys. And value of beta is iota, my apologies, identity matrix I 0 minus I. These are identity elements, okay. So this is the so Dirac Hamiltonian is H equal to C alpha dot beta plus beta alpha dot P plus beta m naught c square, okay, where alpha and beta are Dirac 4 cross 4 matrices, okay, Dirac matrices, okay, and value of alpha is this and value of beta is this, okay. Well, and since we know H psi equal to E psi, right? So from Hamiltonian we have, right, the Dirac Hamiltonian is this. Dirac Hamiltonian is this. So this is going to be H psi E psi, right? So this is the Hamiltonian is this, right? So this is going to be iota h cut, value of h, iota h cut del psi upon del t equal to E psi equal to S psi, S psi equal to E psi, right? This is the equation. So this is going to be, this is the value of h, right? This one, Hamiltonian. So this is going to be C into alpha dot P plus beta m naught c square, beta m naught c square, and we have taken psi, okay. This is the one, and now I will write it in Hamiltonian form. So this is going to be I h cut del psi over del t equal to minus iota h cut, okay, iota h cut c, because we have put the value of p. P is I minus iota h cut del upon del x, right? The del, right? So this value is going to be this, we have taken common. So this is going to be alpha dot delta, right? Alpha dot delta, because here we know, right, is equal to minus iota h cut delta. We have put this value delta plus beta m naught c square psi, right? So this is iota h cut del psi over del t minus iota h cut c, okay, we have put the value minus iota h cut c alpha dot delta plus alpha dot del plus beta m naught c square psi, okay, this one, this is the psi value, okay, this one, this value, this is called Dirac equation, guys, okay, Dirac equation. Dirac equation very important. You need to note down and memorize this equation, guys. Very important. You may ask directly this question. Okay, what is the Dirac Hamiltonian or Dirac equation? Okay, so this is iota h cut del psi over del t equal to minus iota h cut c into alpha dot delta alpha dot del plus beta m naught c square psi. This is Dirac equation. Okay. Well, so now I'll explain properties of Dirac matrices. Okay. So properties of Dirac matrices. Properties of Dirac matrices. Properties of Dirac matrices. Okay. So first property is alpha I square, that is alpha is alpha. Okay, alpha square is going to be 0 sigma I 0, right? Because alpha I value is this 0 sigma I sigma, right? This into 0 sigma I 0. Okay, so we'll solve it. So this is going to be sigma I square 0 0 sigma I square. Okay, and from here this is going to be I 0 0 I. Okay, so we can write this in this form. This is 1 0 0 1 0 0 0 0, and this is 0 0 0 0 1 0 0 1, right? We can write like this, and this value equal to I. So alpha I square is, or alpha I square is, this is the Dirac 4 cross 4 Dirac matrix, right? Matrices. So alpha I square is I. Okay, first property. Now next is this one. This is beta. This one is beta square is beta value, you know, right? Iota 0 0 minus iota, right? And this is going to be iota 0 0 minus iota, right? So this is going to be iota 0 0 iota. Okay, and this value is also iota. So alpha square equal to iota, my apology, alpha square equal to I, that is identity matrix, and beta square equal to also I, that is identity matrix. So these are two properties. Property number third. Okay, so that is alpha I dagger. Okay, alpha I dagger means this is 0 sigma I 0 dagger. Okay, and this value is going to be equal to alpha I. Okay, similarly beta dagger equal to beta. Okay, so these means this means Hermitian. So alpha is Hermitian matrix. Okay, Hermitian matrix. Okay, and this implies Hermitian matrix. Okay, beta is also Hermitian matrix. Next is fourth property. Property 4 is trace alpha I equal to trace beta I, trace beta. Okay, we can say alpha or beta. Okay? Beta equal to 0. This means involuntary. Okay, involuntary. So it means this implies Dirac delta matrices alpha I and beta. Okay, Dirac delta matrices. Dirac delta matrices are Hermitian, and traceless. Hermitian and traceless. Okay. Property number 5. Dirac delta properties we are doing. Okay. Property number 5 is alpha I beta. Alpha I beta is going to be 0 sigma I 0, and beta value is I 0 minus I. Okay. So we'll solve it. So this is going to be 0 minus sigma I upon, my apology, so 0 minus sigma I, 0 minus sigma I minus sigma I 0. Okay, 0 minus sigma I minus sigma I 0, or this implies alpha I beta. Now, my apologies, so this is, we have found alpha I beta. Okay, now we'll find beta alpha I. Beta alpha I, so this is going to be, beta alpha is going to be I 0 minus I, and 0 sigma I 0. Okay, so this is going to be 0 sigma I minus sigma I 0. This is this value and this is this value. Okay, this is alpha beta equal to 0 minus sigma I 0. Okay, and beta alpha is 0 sigma minus sigma I 0. Okay, so from here we can say, we can get alpha I beta plus beta alpha I. This value is 0. Very important property. Okay, now property number 6. Property number 6 is alpha I beta j. Okay, this value is, will put the value sigma I. This is the alpha I value. Okay, sigma I 0 into 0 sigma j 0, and we'll multiply the matrix multiplication, very simple. Okay, so sigma j 0 sigma j. Okay, this one. Similarly, we'll find alpha j my apology guys, this is alpha j, this is value. Okay, alpha j. So this value is alpha j, just alpha j alpha I. So this is alpha j. Okay, now alpha j alpha I. This is going to be, similarly we'll write, this is sigma j sigma I, simple matrix multiplication. Okay, sigma j sigma I, sigma j sigma I. Okay, so from here we can write alpha j plus alpha j alpha I. This is going to be sigma j plus sigma j sigma I 0 sigma j this is guys sigma I sigma j plus sigma j sigma I. Okay, here sigma I sigma j plus sigma j sigma I. Okay, this is going to be this value, or we can write in short this delta I this one delta I, this is 2i 2i chronica delta ij. Okay, and 0 0 2i chronica delta ij. Okay, right, because if I equal to j, then this will get added. If I and j are not equal to, then value is going to be 0. Chronica delta I have already explained. Okay, so this we can also write. I'm going to write in next page. So we can also write delta alpha I alpha j plus alpha j alpha I. This is going to be 2 chronica delta ij I. Okay, these are the properties of 4 cross 4 Dirac delta, guys. Okay, so guys, what we have studied together, I took 2 lectures today. Okay, the first is Born approximation and second is relativistic quantum mechanics. In relativistic quantum mechanics, we have studied Caroline-Gordon equation, KG equation, its solution, and then Dirac hole theory, and the Dirac Hamiltonian and Dirac equation, which is very important. And then there are 2 4 cross 4 Dirac delta matrices, right? We have studied those properties of those 4 cross 4 Dirac delta matrices. Okay, so guys, now your quantum mechanics is completed, guys. Okay, so I have completed quantum mechanics in 27 lectures. Okay, so I would request you who haven't watched my lecture, please watch my lectures from first lecture to 27th lecture, then you will understand everything. And actually my lectures are going to help you to crack any exam related to physical science, guys. Okay, well guys, so I'm going to stop here. Thank you so much. Bye now.